my daughter was a high school student. At the time, my daughter was a high school student. I told my daughter about this. This is what she said. 不然老师要怎么上课嘞？本来就是应该这样啊。So that's purpose learning. Okay. So I learned from her. So I did my own purpose learning. So from the everything else, not hot and cold, not hard and soft, everything else. So what I do is this everything else. I did smart product design. So I use this example a lot. And so this is the water bottle, and this is copper. This is gum. This is not the smart product. So if we have some temperature sensing and control so that we can keep the water inside the bottle at 60 degrees. This is called mechatronics. In mechanical engineering, a lot of people are doing mechatronics, but this is still not smart. This is still not smart until we put some sensors. Put some sensor inside that water bottle so that the sensor can detect the motion and identify that, oh, this guy is drinking water. So it becomes a little more smart, and that again can be sent into the cloud. So if something is wrong, and the alert message can be sent to some caregivers apps to remind the caregivers. From here, hardware, firmware, cloud, and software. That is smart product. Okay, so this is what we do in everything else. Okay, smart product design. We're talking about smart this and smart that. So I cannot introduce other people's classes. So this is what I do in my mechanical design classes. I love to play basketball. And my design projects are always related to basketball. This is what we do in the past couple of years. We are designing an IoT robot for YBA skill challenge. YBA skill challenge is of course similar to NBA skill challenge. So what people have to do is they have to design a robot that can circle around the defenders and rush back to the basket and shoot a three-point basket. Okay, so these are the rules. But what I want to tell you is that's just the purpose. I tend to give students a purpose, design that robot that does this. But what we are doing here is we try to make students learn all these topics: design concept, transmission, mechanism design, control system, and system integration, and including some IoT control, okay, including some teamwork and presentation, report writing, and so on. And we teach in English, but I have my own explanation of teaching in English. So I call the Taiwanese way of teaching in English. I think what is important is not the professor speaking English, okay? What is important is the student speaks English. So in my class, I do not speak English 100% of the time. Actually, if I started to speak English in my class, I lose several students. So I tend not to speak too much in English. But all the presentations, all the reports by the students are in English. Okay, so this class is taught that. And the other project I'm doing, this is the second semester. This is what they just finished their presentation. I was so impressed by the students' presentation. It is the exercise game design. Design something like V-switch. But of course, our students' project will not be as fancy as V-switch. It will be something like this: a ping pong ball racket with a controller and so on. And what happened is they have this accelerometer to pick up the data, pick up the motion, and they do machine learning. So we actually put machine learning AI into our curriculum, and also they want to transmit everything using Bluetooth to the app, so that they have this fun game they can play with. Okay, so here we also use design workshops. So in my class, actually, I only lecture half of the time. The other half of the time are students' presentations and workshops for skill development and so on. So for data collection, for machine learning, and for prototyping. Okay. So again, I just want to give you a flavor if you take mechanical engineering, what the courses will be like. Okay. So finally, we are going to put generated AI into our design project. Okay. So that's why it is nothing you do at mechanical engineering will be strange. We have everything in mechanical engineering. Finally, this is my last PowerPoint slides. I want to slow down a little bit. I keep looking at that clock. I want to be a good professor and not to talk too much. So this is my very last slides, and I want to tell you that the future needs transdisciplinary talent. If you pick one major, you will be like that T-shaped person. You have one major, and you have probably some breadth, and that is not enough. So people in the business school, they talk about pie shape. You have two majors, double majors. But that is still not enough. We want to be a com shape. Com is 数字. So with the com, there are many T's. And we want to have many different expertise, many different disciplines. And anybody recognize this person? Who is that? Who is this person? Do you know this person? This is Da Vinci. And what do you think about Da Vinci? When people talk about Da Vinci, what do you think about? 蒙娜丽莎的微笑，最后的晚餐, right? She's a very good artist, but do you know that he's an excellent engineer? You know that, right? So this is the transdisciplinary talent we talked about 500 years ago. So that's my expectation for the students, of course, my expectation for myself. And I think mechanical engineering students, there's a perfect chance to become somebody like Da Vinci, transdisciplinary talent. And forget about your major learning with that purpose. Okay, so that's that. And what again from design point of view, and the common language we have is design. And design is a common language. Design is a problem-solving process. Design starts with a problem, and design ends with a solution. So no matter whether you pick any as your major, hopefully you have that thing in mind. Learning with a purpose, not with a major. You are the very small group of guys in this university that have that chance. Okay, so that's the end of my presentation, and hopefully I'm not taking too long. Okay.